All right, now let's build a different version of that same function, but instead of using a for loop, we're going to use a do while loop. All right, slightly different approach. These do loops can be appropriate in different situations where and allow a little bit more flexibility, but we also have to take a little bit more control over how they work. So let's flip back over to VBA. We're going to adapt our function that we have and use a do loop instead of a for loop. So as we come over, we're going to copy this, make a new function here, make some room. All right, square n times, we'll do v2. Make sure we change at the end to v2 as well. All right, we've updated this. And now what we want to change is this middle section. Instead of doing a for loop, we're going to do a do loop. So let me just come in here and we're going to make some more room. And we're going to do a function called do while. All right, so do while works as long as some condition is true. And so the condition here that we're going to start with is if loop num is less than or equal to num times. And at the end of the do loop, we type loop. So the syntax here is we start with a do while, have a condition that is tested whether or not it's true, and then loop. And the way that it works, loop is how it tells it where to stop. And so the way that it works is it says, if this is true, do whatever code is in the middle here. If it's not true, skip over, and you're all done. So that's the basic looping structure. Now we need a little bit more help along the way. So first, we need to tell loop num where to start. So we're going to say loop num equals 1 before we get into our loop. And then we're going to start at 1 and then go until that's greater than num times. Now our code, we're going to do the same thing we did before. We're going to take our answer and we're going to square it. Notice I'm going to take my debugging commands out of the previous function so we don't see them in the immediate window. All right, so we're going to do answer squared. We're going to print our loop num and our answer. So let's go see how this works. So we go square n times v2, hit enter, and we get a value error. All right, let's see what kind of value error we got. Well, the immediate window gives us a little bit of insight here. So what it tells us is the first thing is loop num, it was 1, and then our answer was 25. And then our loop num was 1, and our answer was 625. And our loop num was 1, and our answer keeps getting bigger, but our loop num is never changing. When the loop num doesn't change, it's never going to be the case that loop num ends up being greater than the number of times. So what we've failed to do here is actually increment up our loop num variable. And this is where we have to be very careful that we don't get into what's called an infinite loop. The reason the infinite loop stopped here and we don't just have our computer running forever is notice how big those numbers got at the end, right? We have 8 times 10 to the 178th. It got to such a big number that the computer no longer can handle it. And so that's why our code actually stopped. If you aren't careful about this in other scenarios, though, you could just end up with a blank screen with Excel just locking up. If that happens, you just got to hit the escape button a bunch of times. If you hit escape enough, it generally will stop your code execution. Here, to prevent from this from happening, we have to add this line of code, loop num equals loop num plus 1. So this is another one of those cases where we see that we're taking a variable, incrementing it up. And again, the math is not true here. It's not ever the case that loop num is equal to loop num plus 1. But again, this is not necessarily math. This is computer, right? What it does is it says, let me take loop num out of the locker, add 1 to it, take whatever that value is, and put it back in the locker that is loop num, right? Locker is the variable where it's stored here. So it's just taking this right-hand side of the calculation, which with whatever loop num was, and now assigning that to the variable loop num. Now that we've done that, it should increment back up. Let's go check. Let's actually clear our immediate window, rerun our formula, and we got a really, really big number there. All right, let's try to see what happened. All right, so we started out with loop num as 1, then 2, 3, 4, and then it looped back to 1. So as soon as it got to 4, it went back into 1. So now we got to figure out what happened there. Well, what happened is I had this second piece of code down here that restarted it that I forgot to delete. So this is where we got to be a little careful when something silly happens. Let's delete that, take our old bit of code out, restart again, and try one more time. Hopefully you guys are getting the idea that programming takes a lot of guess and check. Not really guess and check, that's a bad term, but a lot of code and check. Code and check. Make sure your function's working. Make sure you're doing what it's make sure it does what you think it should be doing. In this case, we corrected it. It looks like it's working now. Let's flip back over. Now we see our printout looks like what we were expecting. So with the do loop, it's important we have to control the loop ourselves. We got to start what the variable is, and then we also got to increment it up. That way we don't end up stuck in an infinite loop. Now, why have all this extra power or control over it, right? The for loop did all that for us. It made sure we didn't get stuck in that infinite loop. Well, that's true, and the for loop is great when you know how many times you want to do something. If you want to do it 5 times, it's easy for the for loop to say, okay, I can do this thing 5 times. But what about when you don't know how many times you want to do something? For example, we might want to square a number until it's bigger than some threshold, right? We want to keep squaring it until it's bigger than something. Or we want to do an action until our points are high enough that we can stop, right? There are all sorts of cases where you want to do something until some condition is met, and you don't know how long that will take. That's where these do while functions are much more useful, and that's what we're going to see in the next version that we look at.